Hello, my dear friends and respected teachers. Today, I, Khushi, a student of 12th standard, studying in Amrit Indo-Canadian Academy, is here with the video assignment of physics. And the topic for today's assignment is Einstein's theory of photoelectric effect. Under the chapter Dual Nature of Radiation and Matter. So, let us start from very basic terms of this chapter like work function, photoelectric effect, photoelectrons and threshold frequency. First, let us know what are photoelectrons. So, photoelectrons are the light or photo-generated electrons. Okay, so now what is photoelectric effect? It is the phenomena of emission of electrons from a metal surface when electromagnetic radiation of sufficient frequency are incident on it. Now, what is threshold frequency? It is the minimum value of frequency of incident radiation below which photoelectric emission is not possible. That is, below this frequency, electrons will not be ejected from the metal surface. Now, what is work function? The minimum amount of energy required by an electron to just escape from the metal surface is called its work function. Now, as we are done with the basics of this chapter, let's now discuss about the main topic, that is Einstein's theory of photoelectric effect. In 1905, Einstein explained photoelectric effect on the basis of Planck's quantum theory, according to which a light radiation travels in the form of small packets called photons. The energy of each photon is h nu, where h is the Planck's constant and nu is the frequency of light. So, let us now discuss the main points of the Einstein's theory of photoelectric effect. The first point says that the photoelectric emission is the result of interaction of two particles. One, a photon of incident radiation, and the other, an electron of photosensitive metal. So, this point suggests that only two types of particles are involved in the photoelectric emission. First is the photon of the incident radiation, that is, the ray of light falling as an incident on the metal surface, and second, the electron of the metal on which the ray is falling. Now, next point. The free electrons are bound within the metal due to restraining forces on the surface. The minimum energy required to liberate an electron from the metal surface is called the work function of the metal. So, this point says that the free electrons of the metal are bound due to the restraining forces present in the metal, and the minimum energy that is required to eject an electron from that surface is called the work function of that metal. Next point, third point, each photon interacts with only one electron. The energy of the incident photon is used up in two parts. A part of the energy of the photon is used in liberating the electron from the metal surface, which is equal to the work function of the metal. Second, the remaining energy of the photon is used in imparting kinetic energy to the ejected electron. So, this point of the theory explains about the usage of energy of the photon. We know whenever a photon strikes on the metal surface, it transfers its energy to the electron in two ways. That is, some of the energy is used up in ejecting the electron from the metal surface, while the leftover energy is used to impart some kinetic energy to the electron. So, let us now discuss about the fourth and last point of Einstein's theory, which says that very few photons, even less than 1%, are capable of ejecting photoelectrons. So, now by conservation of energy, what does conservation of energy means? In short, it means that total energy remains constant for a system. So now, energy of the incident photon, that is h nu, is equal to the maximum kinetic energy that can be imparted to the photoelectron plus the work function W naught. So, h nu is equal to half mv square max plus W naught. And if we want to find the value of k max, That is, the value of kinetic energy, it will be equal to h nu minus w naught, because w naught will go to the other side and get subtracted. Now, if the incident ray is of threshold frequency nu naught, then its energy will be h nu naught, and it will just be sufficient to free the electron from the metal surface and does not give any kinetic energy, and hence the k max in this case will be 0. So h nu naught will be equal to w naught, that is the work function. Hence k max is equal to half mv square is equal to hv minus hv naught is equal to, if we take the h common, so hv minus v naught. This is known as the Einstein's equation of photoelectric effect. Now, let us understand the whole concept of photoelectric effect through this video. Now, this video is a summary of what all I have explained you in this video. Now, according to Einstein, the photoelectric emission is the result of interaction of a single photon and the electrons present in the metal surface. Now, as the photon strikes on the metal surface, the energy of the photon is used in two ways. That is, one in extracting the electron from the metal surface, secondly in providing kinetic energy to the particles, that is electron. And the minimum energy required to liberate an electron from metal surface is called the work function W naught of the metal. Now, if m is the mass of an electron and v its velocity, then energy of the incident photon according to conservation of energy is equal to work function plus kinetic energy of the electron. So h nu is equal to work function plus half mv square. Now, if the electron does not lose any energy by internal collisions as it escapes from the metal, the entire energy will be exhibited as the kinetic energy of the electron and will be equal to h nu minus w, where w is the work function. Thus, h nu minus w represent the maximum kinetic energy of the ejected photoelectron. And if Vmax is the maximum velocity with which the photoelectron can be ejected, then h nu is equal to work function plus half mv squared max. Now, both the equations are known as Einstein's photoelectric equations. When the frequency of the incident radiation is equal to the threshold frequency, that is nu naught of the metal surface, kinetic energy of the electron becomes 0, and then the equation 2 becomes h nu naught is equal to work function. Substituting the value of work function in equation 2, we get the above equation that is shown on the screen. Both the equations shown on the screen are another forms of Einstein's photoelectric equations. In numericals, we can use both these equations. I end this video here and hope you have understood. Thank you for lending your precious time to me.